Go. Hello students, I am Dr. A. Pramila and will teach you chemistry. To begin with, let me first brief you about the syllabus of class 11. So you can see here, there are total 14 chapters which you need to study. And it starts with the first chapter, some basic concepts of chemistry. Unit 2 is structure of atom. Unit 3, classification of elements and periodicity in properties. Unit 4, chemical bonding and molecular structure. Unit 5, states of matter, gases and liquids. Unit 6, chemical thermodynamics, that is Unit 6. Unit 7, equilibrium. Unit 8 is redox reactions. So from Unit 8, you will get in Part 2 book. Till Unit 7, that is equilibrium, you can get in Part 1. And from Unit 8, that is redox reactions, you will get in Part 2. Hydrogen is Unit 9. Unit 10, S block elements. Unit 11, some P block elements. Unit 12 is organic chemistry. Some basic principles and techniques you will study in organic portion. Unit 13 is hydrocarbons, and the last chapter, Unit 14, comprises of environmental chemistry. So to begin with, let me start with some basic concepts of chemistry. So some basic concepts of chemistry. You should know first what is chemistry. You are all knowing about what is chemistry, the definition of chemistry. Chemistry is a branch of science which deals with the study of composition, properties and interaction of matter and the changes which the matter undergoes under different conditions and the laws which govern these changes. So basically, chemistry is a branch of science in which we deal about the study of composition, properties and interaction of matter. There are three branches of chemistry. Firstly, it is physical chemistry. Second, it is inorganic chemistry. And the third one is organic chemistry. So in physical chemistry, you will be studying about, it is a branch of chemistry which is concerned with the application of the techniques and theories of physics to the study of chemical systems. So usually we'll study their quantitative aspects. So this some basic concepts of chemistry is a part of physical chemistry. In organic chemistry, there will be studying about the metallurgy part, extraction of metals from their respective ores which are present in the Earth's crust. That part will be studying under a branch of chemistry called as inorganic chemistry. And organic chemistry will be studying about hydrocarbons, that is carbon and hydrogen containing compounds there. So these are the main three branches of chemistry which we'll be seeing. There are many others, but we are concerned, we'll be limiting to that of three main branches of chemistry there. Now you see the importance and scope of chemistry. There are many important applications and you can say that is scope of chemistry. The first one which I am showing you is in supply of food. So in supply of food, with increase in population, with increase in population, the need for the overall amount of food has increased. Moreover, with increase in the standards of life, there has been increase in the quality and variety of food. So chemistry has provided with chemical fertilizers like urea, ammonium sulfate, etc., which have increased the yield of fruits, vegetables, and crops. It has helped to protect the crops from insects and harmful bacteria by the use of certain effective insecticides and pesticides. Also, the use of preservatives. They have helped to preserve the food articles, food products like jam, butter, etc. So this is the application in the supply of food. Let me come to the second application, that is contribution to better health and sanitation. So it has provided mankind with a large number of life-saving drugs. Today, dysentery and pneumonia are curable due to discovery of sulfur drugs and penicillin. Life-saving drugs like cisplatin and taxol have been found to be very effective for cancer therapy, and AZT, azithromycin, you can say, is used for AIDS victims. Analgesics have reduced pain. Antibiotics have helped to curb infections and cure diseases. Antibiotics like, you can say, chloromycin, streptomycin, etc. They have curbed the infection and cured diseases like typhoid and tuberculosis there. Then tranquilizers, they have reduced the mental stress also. So that is how they have contributed to better health and sanitation. The third point is saving the environment. So refrigerants like CFC, that is chlorofluorocarbon, which destroy the ozone layer, have been replaced by environment friendly chemicals. So thus they are saving the environment. Next, fourth point is increase in comforts, pleasures and luxuries. So chemistry has played a big role in increasing comforts, pleasures and luxuries. Synthetic fibers which we are wearing, the fibers which we are wearing, such as sterylene fibers, nylon, rayon, etc., they are comfortable, durable and also attractive in nature there. Then you can see supply of steel and cement. Chemistry has supplied as the construction of it has helped in the construction of safer homes. Then articles of domestic use have made our homes more comfortable, such as we are using detergents, oils, we are using sugar, paper, glass, paints, varnishes, perfumes, then cosmetics, cooking gas, etc. They are helping us in increasing our comforts, pleasures, and also the luxuries. Then the next point, that is the fifth point, is transport and communication. So in transport and communication, almost all means of transport use either petrol or diesel or coal, which are all chemical products there. Next point you see, it is the sixth point, nuclear or atomic energy. Nuclear or atomic energy is used for the production of electricity also. An alternate source of energy, nuclear source, it can also be employed, nuclear source of energy can also be employed for digging funnels and blasting mountains. The next application is application in industries. In application in industries, we'll be seeing that it has played an important role in the development and growth of a number of industries like paper, glass, textile, leather, dye, paints, varnishes, pharmaceuticals, etc. So it has played a very important role, chemistry, in industries also. The last one, if you see, applications in war. Chemistry has also increased the striking power of man in war times. It is responsible for the discovery of highly explosive substances such as TNT. TNT stands for trinitrotoluene, nitroglycerine, and dynamite, and many other deadly weapons like atom bomb and hydrogen bomb there. So these are the applications of chemistry in and scope, you can say importance and scope of chemistry in our day-to-day life. You are all knowing about all these things. We are just recapitulating the things which you have already read. So in this chapter, the things which you have already read will be going a little, will be expanding, and will be going a little vast, will be seeing, and accordingly will be studying. So here you see the question on my screen. It is, name two discoveries of chemistry which have helped mankind and the same discoveries that have harmed the mankind, and how. So I'm giving you two examples. You can give more examples there. The first example which I have given you is discovery of chemical fertilizers and insecticides. That is what I had discussed in the supply of food chain there. The discovery of chemical fertilizers. They have helped in the growth of crops, but how are they harming the mankind? They are slow poisons for the mankind. So that is the first discovery of chemical fertilizers and insecticides, which are helping the mankind also, as well as they are acting as slow poisons for the mankind. The second one is discovery of nuclear energy. I discussed that in importance and scope of chemistry. So discovery of nuclear energy, it has helped in the production of electricity in nuclear reactors, but it has led to making of atom bombs also for destruction. So it has helped the mankind also, as well as the same discovery has also harmed the mankind. You can give more examples. Yes, now let's start with here the chapter matter. You are knowing about the definition of matter. Anything that occupies space and has got mass is called as matter. I repeat, anything that occupies space, possesses mass, and the presence of which can be felt by any one or more of our five senses, that is called as matter. Classification of matter. There are two ways of classifying matter. First is physical classification, and the second one is chemical classification. So physically we can classify matter into three types, that is solid, liquid, and gas. I'll show you all this by the flow chart here. You see the flow chart. Look at the flow chart. Classification of matter. This is, and it's classified into two types, physical classification and chemical classification. Physically, we classify matter into three types, solid, liquid, and gas. And chemically, we classify matter into two types, pure substances, and the second one is mixtures. Pure substances are further classified into two types, elements and compounds. Elements are further classified into three types. First is metal, second is non-metal, third one is your metalloids. And compounds are classified into two types, inorganic compounds and organic compounds. Mixtures. Next classification, chemical classification is mixtures. Mixtures are classified into two types, homogeneous mixture and heterogeneous mixtures. This flowchart should be there in your mind for the classification of matter there. Homo, as the name says, homo means having same composition all throughout. So homogeneous mixtures are those which are having same composition all throughout. Example, let me give. It is sugar solution, salt solution, etc. And heterogeneous mixture. Hetero means different. Heterogeneous mixtures are those that are having different compositions all throughout. So example of heterogeneous mixture is sand, water mixture. You can take chalk that is suspended in water. They all come under heterogeneous mixtures. Okay, now let us come to the next part. Next slide. And it is definition of an element. An element is defined as a pure substance that contains only one kind of particles, and these particles may be atoms or molecules. Element example you can give: iron, aluminium, gold, silver, etc. Compounds, they are pure substances containing more than one kind of elements or atoms. So compounds are pure substances containing more than one kind of elements or atoms. Example, let me tell you, here in compounds, you can take water, carbon dioxide, sulfur dioxide, etc. They all come under compounds. Next you see atom. Atom definition you should know. An atom is the smallest particle of an element which takes part in a chemical reaction. So see here, an atom is the smallest particle of an element which may or may not be capable of independent existence. So it is the smallest particle of an element which takes part in a chemical reaction. Then go for molecule. Molecule is the smallest particle of an element or a compound which can exist freely. If I say oxygen molecule, oxygen, hydrogen, chlorine, fluorine, bromine, they are all diatomic molecules. They exist in Cl2 state, chlorine, oxygen, O2 state, bromine, Br2 state, hydrogen, H2 state. So they become molecule, smallest particle of an element or a compound that can exist freely. They are called as molecules. Ozone molecule. Next, let us come to the points of differences between a compound and a mixture. So a compound and a mixture, let us come see the difference. The first difference, the constituents of a mixture may be present in any ratio. That is the difference between mixture and compound. Mixture, the constituents of a mixture may be present in any ratio, and in compound, the constituents of a compound are always present in a fixed ratio by mass. If I say water, H2O, there the elements hydrogen and oxygen are present in a fixed ratio, that is 1:8. Then second point of difference, mixture may or may not be homogeneous in nature, whereas compounds are always homogeneous in nature. Third point of difference, the properties of a mixture are midway between those of its constituents, and here in compound, the properties of a compound are entirely different from its constituents. Fourth difference, the constituents of a mixture can be easily separated by simple mechanical means, and The constituents of a compound cannot be easily separated by simple mechanical means. Energy in the form of heat or light is to be supplied. Next, mixture. Mixtures are formed as a result of physical change, whereas compounds are formed as a result of chemical change. When a mixture is formed, no heat, light, or electrical energy is absorbed or evolved, whereas formation of a compound is always accompanied by absorption or evolution of heat, light, or electrical energy. And the last point of difference between mixture and compound is the melting and boiling points of mixtures are usually not sharp, whereas chemical compounds possess sharp melting and boiling points. Next, let us see the 7 basic physical quantities. There are base physical quantities along with the units. 7 basic physical quantities, and they are length, mass, time, electric current, thermodynamic temperature, amount of substance, and luminous intensity. There are 7 basic units which you have to learn by heart. You are already learnt and you need to keep it in your mind. The 7 base physical quantities there. For this, you can remember the code word LMTETAL. LMTETAL. L stands for length, M stands for mass, T stands for time, E stands for electric current, thermodynamic temperature, amount of substance, and luminous intensity. Length is having the SI unit of meter. Mass is having the SI unit of kg. Time, seconds. Electric current, ampere. Thermodynamic temperature, Kelvin. Amount of substance, mole. Luminous intensity, candela. So you have to learn the 7 basic physical quantities along with SI unit. Next, you see, you need to learn this table by heart, and this table is the prefixes that are used in the SI system. This is, you have to learn. It is there in your book, NCERT book, and you have to learn. You know some basic ones because of it is taught in mathematics, and it is kilometer, hectometer, decameter, meter, decimeter, centimeter, millimeter. You know 1 kilometer equals to 1000 meter if I ask, because you have been asked to remember these things in your previous classes. So here you need to remember a little more, expand your knowledge, and you have to remember prefixes that are used in this SI system there. So you see the minus parts first. Decimeter, you see 10 raised to minus 1. 1 decimeter equals to 10 raised to minus 1 meters. If you see nanometer, 1 nanometer equals to 10 raised to minus 9. 1 nanometer equals to 10 raised to minus 9 meters. If you see 1 picometer equals to 10 raised to minus 12 meters. So you need to remember, because you have to do the conversion of one unit to the other, and for that you have to know the relationship between one unit and the other unit. So 1 nanometer equals to 10 raised to minus 9 meters. 1 micrometer equals to 10 raised to minus 6 meters. Look at the plus part. 10 is deca. 10 raised to 2 is hecto. 10 raised to 2 is hecto. You see here, 10 raised to 2 is hectometer. 1 hectometer equals to 10 raised to 2 meters. 1 kilometer equals to 10 raised to 3 meters. 1 megameter equals to 10 raised to 6 meters. 1 gigameter equals to 10 raised to 9 meters. 1 terameter equals to 10 raised to 12 meters. 1 petameter equals to 10 raised to 15 meters. And similarly, you need to know about till 10 raised to 15, and here 10 raised to minus 15 at least. 1 femtometer equals to 10 raised to minus 15 meters. 1 picometer equals to 10 raised to minus 12 meters. 1 nanometer equals to 10 raised to minus 9 meter. 1 micrometer equals to 10 raised to minus 6 meters, and so on. So you need to learn this in detail, and let us go for the next part of the topic, and it is the difference between mass and weight. So you know, mass is the amount of matter present in it, and the mass of the substance is constant always, whereas weight is the force exerted by gravity on an object, and it may vary from one place to another due to change in gravity. So that is the difference between mass and weight. Mass remains constant, whereas weight changes from place to place due to change in gravity. Next, volume. You know, volume is having the units of length cube, that is meter cube. Density is the amount of mass that is present per unit volume, and its unit is kg per meter cube, or its unit is gram per centimeter cube. Temperature, there are three temperature scales. First one is Kelvin, second one is degree Celsius, and the third one is Fahrenheit. Okay, three temperature scales, and you can interconvert all these three one into the other. For example, if I ask you to convert 27 degrees Celsius to Kelvin, you will add 27 degrees Celsius plus 273 and it becomes 300 Kelvin. Similarly, if I ask you to convert 300 Kelvin to degree Celsius, you will subtract 300 minus 273 to get the answer in degree Celsius, and you get their answer there as 27 degrees Celsius. And for conversion of degree Celsius to Fahrenheit, let me tell you first verbally, then I'll write you on the board and explain the three temperature interconversions there. For converting degree Celsius to Fahrenheit or Fahrenheit to degree Celsius, vice versa, we use the formula there, C by 5 equals to F minus 32 divided by 9, and thus we can do the calculations. Let us come to the next part of this chapter topic, and it is uncertainty in measurement. Very important, you should understand the concept here, uncertainty in measurement. So many times in the study of chemistry, one has to deal with experimental data as well as theoretical calculations, and there are meaningful ways to handle the numbers conveniently and present the data realistically with certainty to the extent possible, and these ideas are discussed below in detail. So here you see we are seeing a new method of calculation, and it is scientific notation method. It is called as scientific notation method. So as chemistry is a study of atoms and molecules that have extremely low masses and they are present in extremely large numbers, a chemist has to deal with numbers as large as, you see the number which is there here on the screen. It is 602.200000000000000. So it's a very big number. For the molecules of 2 grams of hydrogen gas, or as small as 0.00000, see how many zeros are there, 166 gram mass of a hydrogen atom. So it's very difficult to read very big number, or it is very difficult to read, very short, the number that is there, very small number there. So other constants like Planck's constant, speed of light, charge on particles, etc. They also involve large number of magnitude there. So for that we have to find a solution, and the solution found out is to express it in scientific notation method there. So in scientific notation method, yes, it's a real challenge to do simple mathematical operations of addition, subtraction, multiplication or division with such numbers which involve as many big zeros they are, or as small zeros which can be included. You can write any two numbers of the above type and try any one of the operations you like to accept the challenge, and then you will really appreciate the difficulty in handling such numbers. And this problem is solved by using scientific notation for such numbers. Scientific notation is exponential notation, in which any number is represented in the form n into 10 raised to n notation there. So you see here in scientific notation method, any number can be represented in the form n into 10 raised to n notation, where capital N is the value that can vary between 1 to 10, and small n is an exponent having positive or negative values there. So let me express here on the board the scientific notation method. Scientific notation method. So any number can be represented in this scientific notation method by putting it in this form, n into 10 raised to n form, where the value of n, this capital N, ranges between 1 to 10, and this small n value, is an exponent value, and it can be either positive or it can be negative. Okay, this value small n, it can be either positive or it can be either negative, and this value capital N, this value varies between 1 to 10. Let me give you an example and explain this. Look at the first example. Suppose I ask you to express a small number 208 in scientific notation method. To express this number in scientific notation method, first look at the first number. The first number will be the value of capital N. So here the value of this n ranges between 1 to 10. So here the number capital N value is 2. So I'll put the decimal after 2 and I will write the answer here as 2.08 into 10 raised to 2. How did I write 10 raised to 2? Now see here, I am putting the decimal place. You are going from right to left. Okay, so see how many places left you have moved. Here you see 1, 2. You have moved 2 places left. 1, 2. And since you have moved 2 places left, the value of this small n, that is small n, will be positive. It will be a positive integer. The value of this small n will be a positive integer. So here I wrote into 10 raised to 2. So if you move towards left, the value becomes here, the value of n becomes positive. I give another example. Second example, if I write 0.0048 and I ask you to express this in scientific notation method. To express this number in scientific notation method. Now you see this number that is there. This number that is there. Here I will be moving 1, 2, 3. 4 is the number that is there. So this 4 will be the value of capital N. Okay. So the answer for this becomes 4.8. How many decimal places I have moved? You see, this is 1, 2, 3. I have moved 3 places right. So if I move 3 places right, then my answer will be 10 raised to minus 3. So if I am moving towards right, the integer value will be negative, and if I move towards left, the integer value will be positive. That is what is the main part which you need to remember, and you need to express the numbers that are given to you in scientific notation. So if you move towards left, the value of 10 raised to n part will be small n part, will always be positive, and if you are moving towards right, the value of 10 raised to n part will always be negative. Now I give you one more example here. And that example is, suppose I ask you to express, the third example it is 6.003. Suppose I give you this number and I ask you to express this in scientific notation method. To express this number in scientific notation, since already the value of n is there here, so it is 6.003, right? Then you have to express in n into 10 raised to n notation. So the answer is 6.003 into 10 raised to, it will be 0. 10 raised to 0, any quantity is equal to 1. So the value, this whole term 10 raised to 0 becomes 1. So I get the answer in scientific notation method as 6.003. And I have expressed this in also scientific notation. Yes, while you are expressing in scientific notation, remember in your mind that the question and the answer that you are writing in scientific notation, they should match with one another. If they are mismatching, means you have written a wrong answer there. You check this. The question is 0.0048 and you have expressed this in scientific notation as 4.8 into 10 raised to minus 3. You just see. I am checking 4.8 into 10 raised to 3. 4.8 you divide it by 1000 and check 1, 2, 3. So 3 places you are putting the decimal 1, 2, 3. Check whether your question and answer are matching or not. You see question is and the answer are matching 0.0048. That means you have expressed correctly the answer in scientific notation. Here also you see 6.003 into 10 raised to 0. Any quantity raised to 0 is 1. So my answer is 6.003. So while you express in scientific notation method, the question and the answer should always match with one another. Otherwise, if they are mismatching, you are doing it wrong. Now, let me tell you about the temperature interconversions. There are 3 different ways in which we express the temperature, and the 3 different ways are degree Celsius, Kelvin, and Fahrenheit. Okay. Now, degree Celsius, as I told you, if I give you a question, convert 27 degrees Celsius to Kelvin. So what will you do? Kelvin equals to 27 degrees Celsius plus 273, and you get this answer here as 300 Kelvin. Okay? And vice versa, if I ask you to convert 300 Kelvin, convert 300 Kelvin to degree Celsius. So what will you do? You will subtract, right? So you will subtract degree Celsius equals to 300 minus 273, and you get the answer there as 27 degrees Celsius. So these two are clear to you. The third one is conversion of degree Celsius to Fahrenheit. And the question is, convert, third question it is, convert 38 degrees Celsius to Fahrenheit. That is the question. I am giving you the relation, and I hope you will do it. You can do the conversion on your own. I am giving only the formula for conversion. And the formula is C by 5 equals to F minus 32 divided by 9. C by 5 equals to F minus 32 divided by 9. So you put degree Celsius here, the value 38 degrees Celsius divided by 5 equals to F minus 32 upon 9, and calculate the value of F. So you can do this interconversion. Now let me show you the questions that are related to that of scientific notation method. Some questions, you will do it as your assignment. Yes, the question is, express the following in scientific notation. The first question, 0.0048. So while you express this answer in scientific notation method, it is 4.8 into 10 raised to 3 places you are moving towards right. So you see here, you are moving 3 places right. 1, 2, 3. So the answer is 4.8 into 10 raised to minus 3. Why did you write minus 3? Because you have moved 3 places right. Look at the answer for this, 234,000. You are moving 1, 2, 3, 4, 5 places left. So the answer is 2.34000 into 10 raised to 5. Look at the third one, 8008. You are moving 1, 2, 3 places left. 8.008 into 10 raised to 3. Look at the fifth question, 0.0025. It is 1, 2, 3 places. You are moving right. So the answer is 2.5 into 10 raised to minus 3. Look at the ninth question, 6.0012. So for this, 6.0012 into 10 raised to 0. Any quantity raised to 0 is 1. 2.0034. So here also the same, 2.0034 into 10 raised to 0. Thus you will express your answers in scientific notation. So you see, I'm showing you here the answers for the questions which I have asked. It is first one, 4.8 into 10 raised to minus 3. Match your answers with the question and see whether you are able to do it or not. The second one, 2.34 into 10 raised to 5. Third answer is 8.008 in 10 raised to 3. Fourth answer 5.000 into 10 raised to 2. Fifth answer 2.5 into 10 raised to minus 3. Sixth answer 2.08 into 10 raised to 2. Seventh answer 4.597 into 10 raised to minus 2. Eighth answer 5.807 into 10 raised to 3. Ninth one 6.0012 into 10 raised to 0. And the last one, 10th one, 2.0034 into 10 raised to 0. So here I end up with my lecture. In the next video, we'll meet with the addition, subtraction, multiplication, division of these numerals, and then we'll go for significant figures. And till then, have a nice day. Thank you so much.